everybody. It's Ellen Weatherford.
And Christian Weatherford.
We're here with Just the Zoo of Us, your favorite animal review podcast, where we take your favorite animals and we review them by rating them out of 10 in the categories of effectiveness, ingenuity, and aesthetics.
We are not zoological experts. We do a lot of research and try our best to make sure we're presenting information from trustworthy sources.
You know what? Right at the top, before we get into our animals, I actually did want to say thank you to people who've been leaving ratings and reviews. They've been tremendously kind, and they make me really happy.
It gives me a nice bump of energy when I'm trying to do some research on something and having an aggravating time finding something.
It's like at the end of like a Christmas movie where all the kids, like their belief in Santa makes the sleigh fly again. It's like that. Everyone believing in Christian helps him power through the rest of his notes.
It does.
You had some pretty dense notes this week, didn't you?
I do.
I'm really excited about it. I feel like when you get like really into, especially like a niche scientific topic, it's so good.
Let's hope I'm not the only one interested in this one.
I'm pretty optimistic that anyone who has chosen to press play on this podcast is probably going to find it interesting.
Awesome.
So you go first this week, Christian.
Yes.
Let's hear it.
This week, I bring the Acorn Woodpecker, scientific name Melanerpes formicivorus. This species was submitted by Dave Roberts via email.
Thank you, Dave.
Yes, thank you so much. I'll be getting my information from the Audubon website, audubon.org, Animal Diversity Web, of course.
Love them.
And also an article titled Woodpecker Pecking, How Woodpeckers Avoid Brain Injury.
How do they avoid brain injury?
More to come. Author is L.J. Gibson, published in the Journal of Zoology back in 2006. So first up, let's talk about what this bird is like. For those unfamiliar, woodpeckers are birds.
Yeah, for sure. I'm sure there's at least somebody out there that's like never heard of a woodpecker before.
I don't know. They're a pretty wide family. Black and white feathering with a little bit of splash of red on its head, like many woodpeckers have. Not all of them, though.
This is like a classic, iconic woodpecker look.
Yeah. I saw it described as clown-faced.
Clown-faced?
I couldn't find out what that meant.
That's incredibly rude.
I've seen other birds described that way. I don't know what it means.
Nobody is meaner to birds than ornithologists. Like, I don't know what it is that like people who are involved with naming and describing birds have some sort of unbridled rage towards birds. Because you know how like birds will be called stuff like the blue-footed booby, or like the loon. Names for birds are always so mean.
Yeah, and I can't tell if I'm just having a sense of deja vu or if we discussed this already. Maybe I've talked about a bird before that was clown-faced.
Well, we've talked about the booby.
Yeah. So anyway, their adult size they're an average of 73 grams, which is about 2.5 ounces.
Oh.
So birds are lightweight, of course, especially flighted birds.
True.
Like this one. And their wingspan is 13 to 15 centimeters or 5 to 6 inches.
It's not a very big bird.
It's not. Where you can find them, though, specifically the acorn woodpecker, is west and southwestern U.S., western Mexico, Central America, and Colombia. So we don't have them here in our part of the U.S.
No, we don't. We live in Florida.
Correct.
We have our own woodpeckers, just not the acorn woodpecker.
Right. And according to the Audubon website, they're seldom found away from oak trees. And so the most common where several species of oaks occur together, and this ensures against total failure of local acorn crop, as different oaks respond to different conditions.
Oh.
Yeah. So if they have a condition that affects one species of oak, I hope species is the correct word here.
Yeah. Yeah, plants have species just like animals do.
So if there's a condition that's affecting one kind of oak, then hopefully, the other types of oaks aren't affected in the same way. So they'll still have their food reserves of acorns.
That's smart.
Yeah.
That's an important argument in favor of biodiversity.
Right. So I guess that's a bit of a spoiler. Acorn woodpeckers depend on acorns.
Are they eating the acorns?
Yes, and more.
Interesting.
Yeah. They belong to the taxonomic family Picidae, Picidae, which is the woodpeckers and close relatives. So in addition to other woodpeckers, like the red-bellied and pileated woodpeckers we see in our area, this family also contains other related birds like sapsuckers and piculets.
Sapsuckers.
Yes.
That sounds interesting.
I'll actually be talking about that a little bit. Yeah.
Okay, good, because I don't think I'm very familiar with sapsuckers. That's a fun name to say, though.
So our first category is effectiveness, and this is talking about physical attributes that help them do the things they do. And I'm giving an 8 out of 10.
That's pretty good.
Yeah, for the acorn woodpecker. So first and foremost, their ability to peck holes.
We have to talk about this.
So this is something lots and lots of woodpeckers are known for, where they're, doing that distinctive pecking into a tree. Typically, you hear of woodpeckers doing this to get at food, like bugs and things that are living inside the tree.
Right.
This one does not do that. So it's usually pecking holes in tree snags, which is a standing dead tree. I didn't know that word before this.
A snag?
Yes.
That's just a tree that's dead?
That's still standing.
Oh, okay. It
Yes.
has to still be standing.
Yes.
I guess as opposed to a log.
Yes, that is the scientific term.
Okay.
A log.
A vertical log.
So they peck holes in these snags to hoard acorns. So these granary trees, as they're referred to, can be used for generations and can contain up to 50,000 holes in them.
Oh my goodness.
Yeah.
Okay, so they're not just pecking one big hole to put all their acorns in.
No, it's a hole that fits one acorn.
Oh my gosh. Surely there must be a more efficient way to do this. To have a 1-to-1 hole to acorn ratio.
I guess that ensures the acorn's not going anywhere by accident. Like something has to be purposely trying to get it out of that hole.
I suppose so.
Yeah.
That's ridiculous.
And like I mentioned, unlike most other woodpeckers, it will rarely or never excavate wood to find insects.
Okay. It's really all about the acorn.
Yes. They do, however, eat insects, but it's usually like cotton flight type of insects. They also might be pecking holes to feed on sap. So this is where the term sapsucker comes from. So those birds are doing that primarily, but other woodpeckers like this one will also drink or eat sap. I'm not sure which is the more appropriate term for that.
Sure. Consume.
Sure.
Ingest. Sap.
Lick.
Put in mouth.
Yeah. So yeah, they'll put these holes in the tree so that, sap in a tree can escape and dribble down, and then they'll lick it up. They'll also use this pecking to excavate nests to lay their eggs in. So these are like big holes.
Okay, so they have the capacity to make a big hole, but choose not to for the purpose of storing the acorn.
There's got to be a reason.
That just seems like the least efficient way to do that.
I don't know. So my next point here is the anatomy that allows it to use its face as a jackhammer, basically.
Yeah, for sure.
So this is where that article comes into play that I mentioned earlier.
Because this is a high impact activity.
Right. So according to that article, they can do this without injuring themselves for 3 reasons. So first is their small size reduces the stress on the brain for a given acceleration. So my high school and a little bit of college level of physics, one of the biggest things you learn in physics is force is equal to mass times acceleration.
Ah, yeah. I remember this one.
Yeah.
This is one of the ones that lasted in my brain.
Use the force. So what that means is for a given acceleration, if the mass is larger, that's a larger force. Right?
It's all coming together.
Yes. And acceleration describes the change in velocity or speed, and velocity describes the change in distance.
Go more fast, bigger force. Go less fast.
Well, not just go fast, but increasing speed.
Oh, sure.
Or decreasing.
Go faster.
Right. So the second one is the short duration of the impact, which increases the tolerable acceleration. Tolerable acceleration is how fast can they accelerate without injuring themselves. Now, this might seem counterintuitive, right? To say a shorter duration lets them endure more. So think of it as the brain can take more of a beating if it's for a shorter period of time.
I guess that makes sense.
So, and anything above that tolerance results in brain injury or a concussion.
Yeah.
So we have this measurement in humans too. So just to understand like the magnitude of time we're talking about here, the typical duration of an acorn woodpecker's head impact is 0.5 to 1 millisecond. So a millisecond, you can fit 1,000 milliseconds in a second.
Right.
So usually we're only talking about milliseconds when we're talking about like computers and things happening at that level, like with networks and that sort of thing.
I was going to say, like, I could insert some sort of audio signal that would like a beep for that period of time. But even if I did that, you wouldn't be able to hear it.
Yeah. Nope. So the acorn woodpecker's tolerable acceleration for that duration is 4,600 to 6,000 Gs. So a G being, you hear this a lot when you're talking about astronauts.
Oh, yeah, sure.
Yeah, so
like a force of gravity?
Right. Whereas an astronaut will maybe experience around 3 or 4 Gs.
Oh, okay. That's a sense of scale then.
Yes. But it's all about that duration because that's happening, across minutes, right? Mm-hmm. Whereas this is a fraction of a second.
Right.
So, but its actual acceleration was measured to be between 634 to 1,525 Gs, so well below that threshold of causing injury to itself. Now, the typical duration of human head impact is 3 to 10.5 milliseconds. The tolerable acceleration for a human across that duration is only 80 to 160 Gs.
Okay, so they're doing it much faster, and also
they have a higher tolerance.
They have a higher tolerance.
Yes. So what this also kind of ties into is this idea of controlling deacceleration to avoid injury. So this is the primary purpose of airbags in cars.
Oh, okay.
Right. Because what it's doing is, instead of going from, 80 miles an hour, whatever your speed you are in a car, and hitting a brick wall and pretty much hitting zero instantly.
Yeah.
It's spreading out that deacceleration because it's basically a big airbag and it's like catching you and slowing you down across a wider period of time.
It's a more gradual stop than a sudden stop.
Right. It's still going to hurt, but not as much.
Less.
And the third thing that helps them with this is the orientation of their brain within their skull. And that increases the area of contact between the brain and the skull.
Oh, really?
Yeah.
Huh.
So rather than all that force being applied to a small area, it's spreading it out.
So the brain is like braced for impact.
Right.
The brain is like, we're ready to go.
And to kind of go along with that, like most woodpeckers, they have a really long tongue that wraps around the back inside of their skull.
It like cradles their like brain. It's so weird. Look up a picture, please.
Yeah,
it's absolutely wild.
And in this species, it seems to be mostly useful for eating sap. Because again, this species isn't trying to dig insects out of wood and stuff. But this would be useful for licking up sap.
So the tongue starts like way, way, way back at like the base of the skull. And it
like goes all the way around up and pretty much almost to their eyes.
Yeah. When I think about that, it makes my head feel tingly. Do you know what I mean? Like thinking about what it must be like for your tongue to be wrapped up inside your head like that. Like a Hubba Bubba bubble tape.
Basically. So that wraps up effectiveness.
That's pretty good. Okay.
Yeah.
They have like they're built for a very high impact activity, an activity that in another bird would be quite painful.
Right. Our next category is ingenuity. This describes, smart things they're doing. Could be pack tactics, tool use, that sort of thing. I'm giving a 7 out of 10. So to our earlier point, I want to give them, points for storing food in holes.
True.
Right.
It does help to do that.
So they do this in the fall, then continue feeding on the acorns the rest of the year. That's particularly important in the winter when their other food sources aren't as available.
True. Acorns aren't going to like go bad,
Right.
like you can put them away they're pantry friendly.
But they'll also store insects in cracks and crevices.
There you go. That's my little pocket ant.
Yeah.
Keep that for later.
They're kind of like the squirrels of the birds, I suppose.
Oh, I like that.
My next point is they team together to defend their granaries.
Oh, good.
Yes. So they're in small groups a lot of the time, and then those groups will defend the granary that they all use.
They have an army to defend their fortress of acorns.
And my next point is sticking it to the human.
Okay.
They cause property damage a lot.
Anarchist icon.
Yeah. So it's not really understood, how they choose buildings and such to do this to, but they'll try to do this behavior a lot in like siding and the eaves of houses and stuff and putting these holes in. Other woodpeckers are known to do this too.
Yeah. We've had it happen when I was a kid. We lived in a 2-story house, and one day we heard this kind of like very persistent knocking sound. Right. And could not figure out what it was. And then it ended up being a pileated woodpecker. Yes. That was pecking on the side of our house.
So woodpeckers can cause damage and some grief for people in that they do this with structures, but also maybe trees that they don't want having holes bored into them.
True, yeah.
These could be, like decorational fruit trees, that kind of thing.
Oh, yeah.
Yeah.
If you have a tree that's meant to look pretty and then it is covered in acorn holes, you get that trypophobia effect.
Yeah.
That you see, that you get from like the Suriname toad. Like we talked about trypophobia with the Suriname toad.
Yeah. So I actually have that in my miscellaneous info.
Okay. I'll let you save that for that. But I could see why that would decrease the value of an ornamental tree.
Well, I've also seen, not necessarily for this species, but in general, woodpecker damage can negatively impact the health of a tree. So it kind of opens up pathways for, disease and fungus and other insects, that kind of thing.
Sure, yeah, it's not healthy for a tree. But if you're a bird and all you care about is making holes in wood, like up until the last, few centuries or so, it hasn't mattered what wood you make holes in,
Right.
That's human use of, wood for non-woodpecker purposes is a pretty recent development.
Yeah.
They just haven't caught up yet.
Yeah. So the general solutions on trying to solve such an issue with woodpeckers, they generally involve removing what's attracting them. So that could be, for some species, the insects they're trying to get at, or scaring them away. Ways I've seen people doing this is using fake, predator bird statues that you'll see sometimes on houses.
Yeah.
Or hanging mirrors within the line of sight of where you're having woodpecker problems.
Oh.
Because it scares them off.
Oh, clever.
Yeah. Or just kind of covering up what they're trying to poke at and repairing the damage.
Yeah. I've also heard, I don't know if you had this in your notes, but I've also heard of people like playing the sounds of predators nearby.
My small amount of anecdotal experience with that is those systems are very expensive and not super duper effective.
Oh yeah, you said they tried to do this where you work, right?
Yeah, so my workplace had tried to use a sound system to keep the Canadian geese away, because the campus of my workplace has lots of, grass and lots of water features, like most of Florida.
Prime real estate for the Canada goose.
So they were trying to keep them away, one, because, they get very aggressive when they're laying nests and such.
They're so mean. They're so mean.
But also they make quite a mess on the concrete and such.
It's poop. Make a poop mess.
Yeah. And then at this campus, they host, lots of business people for that kind of thing.
So they have to make sure they keep their fancy, shiny shoes goose poop free.
Yeah. That didn't work out too well for them from what I understood. They eventually just hired a person with a trained border collie that was just trained to chase off the geese, not hurt them, not touch them, just, chase after them and bark. And that turned out great, actually.
That is probably the most brilliant, genius thing I've ever heard. Just like, hey, we'll just get this guy to bring his dog, let the dog go have a fantastic time to keep the geese away.
It was always nice seeing the dog too.
Yeah, because that's really the perfect solution, right? Because it's fun to look at.
Yeah.
It's nice to see. It makes people happy and it keeps the geese away.
Yeah.
It's a win-win for everybody, except the geese.
Go somewhere else.
Go home.
Sorry about that tangent.
We're all about tangents here.
My next thing for ingenuity is shared parenting.
Love it.
Multiple females in the group will use the same nest to lay their eggs, and then the parents and helpers will take turns incubating the eggs. And then that behavior continues with feeding them once they're young.
That's so nice.
Yeah. There's more details that I didn't want to really get into.
Oh.
A little bit of violence in there.
Oh.
But
It's the animal kingdom. What are you going to do? We can't hold them all to human standards of morality.
Yeah. And then my last thing for ingenuity is when they do their sap sucking, they're doing it communally. So they'll have a tree where they do that, and then they'll kind of come together to do the sap sucking.
Aw. It's like a family table.
Right.
That's such a timely thing for Thanksgiving coming up. It's
Right.
the whole family, the whole community all gathering together to share a meal together.
Yeah.
I'm so glad we were able to tie this into Thanksgiving. I'm the worst about remembering to do holiday themed episodes.
It takes some planning.
I know, and we didn't do it.
So our last category is aesthetics. So this one is how cute or pretty or beautiful they look and appear. I'll give it a 7 out of 10.
That's pretty good.
Yeah. So I said I put this in my miscellaneous info, but I actually put it in my aesthetics.
I can see how.
The trypophobia. So it's not really them, right? It's what they produce, though.
True. It's them adjacent.
Right. So trypophobia is the fear of closely packed holes. So we talked about this with the Suriname toad. Other examples of this, I think, are lotus pods.
Oh, yeah.
With their seeds.
Lotus seed pods, have a bunch of clustered holes.
Yeah. I've even seen this extend to things like honeycomb.
Sure.
And like little pockets in cement, that kind of thing.
Yeah, like sponges maybe even.
Yeah. It's not formally recognized as an actual phobia.
But I get it. It's unsettling. It is. I wouldn't say that I have a phobia, but I get the squeamish,
Right.
I get how it can make you kind of uncomfortable to look at.
And that's why it's because, that imagery usually leads to disgust. Whereas for something to be considered a phobia medically, it's supposed to cause distress.
Sure.
And affect quality of life.
Right. Whereas I'm sure you're not going to be encountering things of this sort of texture often enough for it to impact your life that much.
Or I guess, just of those that do experience this, it's always more of a feeling of disgust than fear.
Yeah, I would say that.
Yeah.
It is nasty.
Aesthetically, the splash of red is nice.
It is nice.
Yeah.
The black and white and red, that is a tried and true color combo.
It's good stuff.
It works on every animal. Never have I seen a black, white, and red animal that I wasn't just like, perfect. But like you said, we do have other woodpeckers here that follow a similar color scheme.
Right.
So we have the pileated woodpecker, which is the one that it's mostly black and white, and it has the red crest on top. And it's got the pointy crest.
Yep.
That's how you know it's our pileated woodpecker.
Yep.
It's got that little point on top.
Mm-hmm.
And then I think our red-bellied ones are black and white too.
They are.
They have don't they have some brown on them too, though?
I'm not sure.
They're
the same smaller and harder to see.
They are. It's a general idea, though.
Yeah. So in terms of miscellaneous info, their conservation status is of least concern, but their reliance on specific oak habitats may make it vulnerable to the effects of climate change. Mm. So that part of the country and continent has problems with forest fires.
Yeah.
So that kind of thing is something to keep an eye out for. And earlier I mentioned ways to combat woodpecker damage. You'll notice I did not mention killing them.
Oh yeah, don't do that.
A big reason to avoid that is all woodpeckers are protected by the Migratory Bird Treaty Act in the USA.
Oh, I didn't know that.
Neither did I.
Oh, that's interesting.
There's a couple species that are actually protected by the Endangered Species Act, but not this one.
Wow.
So there is a whole process to where you can lower their population through a permit if you need to, but it involves showing proof of you've already tried the other things.
Sure.
And can show, loss of things like property and income and stuff because of the damage.
I mean, there's other ways, y'all.
Yeah.
Be cool. Be nice. Be nice to woodpeckers, please. Even if they might not be super nice to your things.
So yeah, that's the acorn woodpecker.
That's a really interesting woodpecker. I'm going to have to keep an eye out for those granary trees next time if we make our way out to the West Coast.
Yeah. And I think in our neighborhood, you can see some of these standing dead trees where you see a single hole bored into it.
Yeah.
I'm betting that's nests of our local woodpeckers.
They might be made by the woodpeckers, but they're probably in use by other things.
And actually, this is an interesting topic for our listeners to look up if they're interested. But this whole life cycle of a tree, starting when, it starts to die, is dying and still standing and starting to fall down, it has all sorts of interesting ecosystem roles throughout that life cycle. Oh,
yeah. There's no better place to look for interesting little critters than a nice log.
Yeah.
Oh, you find a log on the ground, there's going to be something good in there.
It's basically the whale fall of the forest.
It is. Oh, that's such a good analogy. Yeah. You can find millipedes. If you're looking for a good millipede, you just crack open a log. I probably shouldn't say just go crack open a log because I don't think you're supposed to be just doing that. But if you can kind of get a good look from a safe distance where you're not going to be disturbing things that might be living inside of the log. Salamanders like to live in logs or under logs, nice frogs and toads.
Fungus.
Oh, yeah. Oh, that's always the logs around here always get covered in turkey tails and stuff. You get some beautiful fungus growth on a good log.
Yeah.
Logs are just... You see a good log, I feel like whenever we're out hiking or on a nature walk or something, if we see a log on the ground, I feel like we need to take a quick diversion. Just a peek. Just a quick little detour to go check out this cool log. You never know. There could be some treasures in there.
Yeah, be careful though.
Forest treasures. Yeah, be careful. There could also be snakes and spiders and stuff that, just be respectful of the forest. Love logs, love snags, love woodpeckers. Great animal. Thank you so much, Christian.
Thank you.
let's take a quick break to hear some promos from our neighbor shows on the Maximum Fun Network, and then let's get to my animal.
Do you sometimes wonder whatever happened to the kids at your school who really loved Star Trek?
You might remember a kid like me, the one who read the Star Trek novels and built starship models. I also took music classes to avoid taking gym classes that required showering after, but I don't see what that really has to do with...
Or a kid like me. I introduced myself to kids at my summer camp one year as Wesley. But when the school year started and some of those kids were in my new class, I actually had to explain to my friends that I had tried to take on the identity of my favorite Star Trek character. The shame haunts me to this day.
I'm sure some of those Star Trek fans from your childhood grew up to have interesting and productive lives, but we ended up being podcasters.
On The Greatest Discovery, you'll hear what happens to two lifelong Star Trek fans who didn't grow up to be great people. They just grew up to be people who love jokes as much as they love Trek.
Season 4 of Star Trek Discovery is here, so listen to our new episodes every week on MaximumFun.org or wherever you get your podcasts.
Hi, it's Jesse Thorne, the founder of Maximum Fun. It's the Thanksgiving season, and I want to take this opportunity to thank you, the members of Maximum Fun. This Max Fun Drive, your generosity and your love of pins helped us raise over $90,000 to help bridge the digital divide. Families without internet access struggle to do things that the rest of us might take for granted, especially during COVID. Going to school, applying for jobs, finding medical care. Your donations help the nonprofit Everyone On. They provide equipment, services, and training to get people online so they can access opportunity. You can find out more about the great work Everyone On does at everyoneon.org. Thanks for supporting Maximum Fun. Thanks for supporting Everyone On. And thanks for being awesome people who want to do good in the world.
So enough about the woodpecker and logs. What animal do you bring us?
Well, this week, I'm really excited. I've been so looking forward to telling you about this. This is the West African lungfish.
Oh.
The scientific name is Protopterus annectens. This species was submitted by Jennifer Myers via email. Thank you so much, Jennifer. Truly, thank you. This is, I don't know if I would have gotten around to talking about this animal on my own, so I'm so thrilled to get to do that. So thank you for giving me an excuse to talk about this cool fish. And I'm getting my information from National Geographic, the San Diego Zoo, the Oregon Zoo, which actually has these lungfish at it, and also a website called Fishbase. Which is a really great repository of fish information. And then there are like a couple of little sources that I'll cite when they come up, because if I tell you what they're called now, it will be a spoiler. So let's talk about the lungfish. There are a few different types of lungfish. Some of them live in South America. Some of them live in Australia. But this one, being the West African lungfish, lives in Africa. This is a long eel-shaped fish with fins that are long, skinny, and I would call them whip-like. So they're like pectoral fins are kind of shaped like a whip. Like they're long and pointy. They don't fan out like other fish's fins do. Yeah. This is a very noodly fish because they're kind of like eel-shaped, you know? So they're all like long and streamlined and wiggly. And then they have wiggly noodle fins. So like...
Interesting.
Yeah. The largest one ever found was a meter long, which is 3.3 feet.
Big.
It's big. And 4 kilograms, which is almost 9 pounds. So it's pretty big. They're found in freshwater habitats.
Okay.
It's a freshwater fish. They live in rivers and floodplains throughout Western and Central Africa. Their taxonomic order is called Dipnoi. This is the order of the lungfish, which is a pretty like broad classification when you're talking about taxonomy being an order. There are only 6 known species in this order of lungfish. So taxonomy here is actually, y'all know, I'm not a taxonomy person. I don't usually get into taxonomy weeds. But here it's fascinating, not because of like naming categories and stuff like that, but because it tells a story. Like it tells like an evolutionary history story. And I love a good evolutionary history story. This is a good one. So mammals, as well as reptiles, amphibians, birds, those are all types of animals called tetrapods. So this means that they have 4 limbs. That's what that word means, 4 limbs. So for us, it's arms and legs. In other tetrapods, those may be all legs or maybe wings. But the gist of it is that we have 4 limbs rather than, say, 6 or 8. So tetrapods had to develop this 4-limb body plan from essentially a fish starter kit, right? Because we started as fish way back when. So in this sort of transition from fins into full-blown arms and legs, early phases had fins that were basically like fins that had muscle and bone in them. So it looked kind of like a short, stubby leg with a fin at the end of it, sort of.
Okay.
And then the rays that formed the fins had bones that later became fingers and toes. Fins like this that have like muscle and bone in them, they're called lobe fins. And you can see them particularly well in a very large lobe-finned fish that still lives today in the deep ocean. It's called coelacanth. Do you know about coelacanth?
Yeah.
So coelacanth is this fish that's usually called a living fossil.
Right.
Right, because it has been so unchanged since we have fossil records of it going back hundreds of millions of years, and it still pretty much looks like that.
Well, was it also because they didn't think it was still around?
Right, yeah. So they thought, scientists thought it had been extinct for about 80 million years.
Right.
And then in the 1930s, just found one chilling in, I think it was in South Africa. They found, like, in the waters off of the coast of South Africa, that they found a coelacanth just like vibing out there. But so the idea is that over hundreds of millions of years, the limbs of the lobe-finned fish grew longer, and eventually the rays became fingers and toes, which you can still kind of see if you look at our skeletons. Like the skeletons of these lobe-finned fish kind of start to look like legs with hands, you know? So all tetrapods evolved from these ancient lobe-finned fish, putting us technically in the fish family tree. So other lobe-finned fish are more closely related to us than they are to ray-finned fish, which are the rest of the fish, basically.
Sure.
So coelacanth and lungfish, the lobe-finned fish, they're more closely related to us than they are to any other fish.
Yeah.
But basically, tetrapods are lobe-finned fish that made their way out of the water.
Sure.
Permanently. Some of us made our way back into the water, right? Like marine mammals, right? So like whales, they made their way out of the water and then decided that they had it right the first time and turned around and went back. But
I want to be big.
yes, I would like to be very large. But it's important to note that this does not mean that humans evolved from lungfish, right? Don't look at a lungfish and be like, oh yeah, that's like my great, 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 great times a million grandparent, No, they evolved from this common ancestor, but we didn't evolve from lungfish.
Yeah, let's just get out in front of that. Why are there still lungfish?
No, absolutely not. I'm shutting that down right now. So most of the lobe-finned fish, including our direct ancestors, went extinct millions of years ago. So whatever common ancestor we evolved from is no longer here. It's just we're still here and the lungfish are still here, kind of like cousins. So lungfish, like the coelacanth, still strongly resemble fossils of their ancestors from about 400 million years ago. So lungfish today look almost exactly like lungfish did 400 million years ago, which for context, this is in the Devonian period. This was before trees existed.
Oh, okay.
So this is also before tetrapods had fully made their way out of the land yet. So if you were to step into a time machine and travel back to the first lungfish, the land would mostly be ferns and moss and some bugs. Some bugs had made it onto the land by then. I think millipedes and some types of spiders had made their way onto the land. But dinosaurs were not even close yet. Dinosaurs had not been invented yet. This was so long before dinosaurs the lungfish was just there chilling. And they're still here today, which I find really interesting.
Yeah.
That you could go back that far and find something so familiar.
I guess that makes sense that they have remained so unchanged, because otherwise they would probably not be lungfish anymore, right?
Yeah, but it is interesting to find something still here that so closely matches what it used to look like so long ago, because that just indicates some level of success, I guess. You know, that they haven't needed to adapt so much, even though the environment has changed so drastically. See this in like horseshoe crabs was when, like we talked about, right? That like horseshoe crabs have basically been the way they are like since the first draft, basically. So yeah, lungfish are just really interesting. They're a really cool example of like the transition from life in the water to life on land. And I just think that having that like context of knowing like the significance of their current like form makes me appreciate them more when I see them. Okay, so the ratings for the West African lungfish. For effectiveness, I'm giving it a 9 out of 10, which is probably not surprising because considering that they've had this form for so long, you know they must have gotten something right. They've essentially just needed no revisions in 400 million years. So lungfish, as their name would imply, have lungs.
Okay.
There you go.
That's good.
So when they're babies, they have external gills, but then they lose them as they grow up. So they actually are obligate air breathers, which obligate means they absolutely have to. So they have to come up to the surface to breathe air. They have to do this at least every 30 minutes. You've actually talked about this briefly with, I think it was the electric eel, a type of knife fish.
Yep.
That since it lived in very, very murky, muddy waters, there was not a lot of oxygen in the water, so they had to come up to the top to breathe.
The shape similarity between this and the electric eel had me paranoid that one or both of its name, lungfish, was going to be false.
Oh.
So I was like, is it not a fish?
No, it's both. It has lungs and it's a fish.
How refreshing.
I know. We come from so many animals where like it'll have like 3 different things in its name that have nothing to do with it.
2 lies and a truth.
So yeah, the lungfish does have lungs. It's very helpful for fish that lives in floodplains because this part of the world doesn't have the same types of seasons that we have, you know, over here where we live. It's not so much a hot and a cold season as it is a dry and a rainy season.
Right, which is the kind of norm for places close to the equator.
Right. So during these dry seasons where it can go months at a time, you know, with no rain or anything like that, the floodplains and the riverbeds that they live in, they dry up, you know, and there's no standing water laying around for the lungfish to swim around in. So they have an interesting way of surviving these dry seasons that I'm actually going to get into in Ingenuity.
Okay.
But they can breathe out of water, basically. It's a very important thing for you to be able to do when there are long periods of time in your life in which you will not have access to water. Good tool in your belt. So you've talked about another fish that could come totally out of water. You talked about the mud skipper.
Right.
Mud skipper is not related to the lungfish. It just has some adaptations that get similar results.
Yeah.
So you talked about how the mud skipper basically just holds on to water for later, and then it just moves that water over its gills when it needs to later. It's not necessarily breathing the air. It's just keeping water for when it needs it.
Right.
When you talked about the mud skipper, you know, the mud skipper needs to go back into the water to get water to breathe. But for the lungfish, it's the opposite. It needs to come out of the water to get air to breathe. So another way that lungfish have really made a life for themselves on land is with their fins, which, as I mentioned, they're not like fanned out like other fish fins are. And they can move these long flexible fins in alternating steps. This resembles walking, except they're kind of using it to like propel themselves. So it kind of ends up being more like a hop, like a wiggly hop.
It's perambulate, I think the word.
Yeah. So it's not quite as smooth as like fully refined tetrapod walking. There is a really funny illustration that I saw on Wikipedia, and it is of them walking using these fins, but their fins are like fully extended. So it looks like they're like a dog with like noodle legs. It's really funny.
I'm thinking of that one Sonic drawing for some reason.
I think I know the one you're talking about. It looks like it's like a weird dog hoisted up on these little like strings. It's really funny. Okay, this was like totally unrelated to all that other stuff, but something that I found when I was doing my notes for this. This is thrilling. I love this. They have an ability that really ties them to amphibians.
Oh?
particularly salamanders, and it is their ability to regenerate lost body parts.
Oh boy.
Salamanders can famously do this quite well. If you chop off a salamander's tail, they can usually grow it back pretty well. So a lot of animals have the ability to regenerate lost body parts, but of note is that in the lungfish, the process by which the body repairs its limbs is the same as the process in salamanders.
Huh.
So it's just another example of that sort of transition between fish and terrestrial animal that you can see that like the lungfish has these features that a salamander also has. I think that's just such a cool little tie-in. Like you can see these things they have in common that just makes them feel so much more familiar.
Yeah.
I think so, at least. You're going to love this. Okay. You're going to think I'm kidding, but I'm not. The process involves a signaling molecule called SHH. Capital S, lowercase h, lowercase h.
Uh-huh.
Do you want to take a stab at what SHH stands for?
Wait,
It's a signaling molecule used in all sorts of body processes, but I'm particularly talking about the regenerative process.
Send ham here.
That's a great one. But this signaling molecule is called sonic hedgehog.
What? No way.
I'm not kidding. That's what it's really called. It's like mentioned in the study that I was reading.
Oh no.
It's called Sonic Hedgehog. It is okay. So I will go ahead and cite the article now. It is from a very recent study. It was called Salamander-like tail regeneration in the West African lungfish by researchers at the University of Chicago and UFPA in Brazil. And this was in September of 2020.
Wow.
So this was just a year ago that this study came out. This is breaking news, folks. This is like hot off the press. But yeah, this signaling molecule is called Sonic Hedgehog, which this protein is like involved in a lot of processes in the body. And so I've seen it pop up here and there during the times that I've been doing notes on like biological processes.
Okay.
And so I'd kind of seen it referenced here and there, and I'm really glad I got an excuse to actually bring this to your attention on the podcast.
So any indication of why it's called that? Or
I mean, I really don't know. People forget that scientists are human beings. And human beings have senses of humor.
This seems like the biology version of a computer programmer naming a variable just some garbage name that has nothing to do with anything, just thinking no one's going to see this.
like hiding profanity in the notes.
Yeah. That's funny.
Yeah, it's a signaling molecule called Sonic Hedgehog. It's on Wikipedia. It's funny because you have to go to like Sonic Hedgehog and it says like disambiguation. Did you meant Sonic the Hedgehog, right? No.
This again.
Yeah, I like to imagine that it was just, a scientist that was just trying to inject a little bit of humor, a little ray of sunshine into their day.
I need answers.
I'm going to call this. Listen, if you're listening to this podcast and you were the one that called it Sonic Hedgehog, please reach out. I'd like to speak with you immediately. So yeah, that's the thing on their regeneration. I did give them a 9 out of 10 instead of a 10 out of 10, and that is because lungfish are a favorite meal for shoebills, which we've talked about a long time ago.
Really?
Yeah. Actually, I mentioned that, like, when we talked about shoebills, is that they just love lungfish. Like, just gobble them right up.
Are they tasty?
I mean, apparently, for the shoebill, they really love them. And shoebills are really good at just snapping them right up. They're, like, specifically built for, like, propelling their face into the water to grab them. And then there's just nothing the lungfish can do about it, right? Like, they can't fight back. They don't have anything on their body to do anything about it. They're like large adult size is pretty much all they have going for them. And that actually does help them against most predators that would be interested in them. But the shoebill is kind of like bulky enough that it can even pick them up at a pretty good size.
Yeah.
Yeah. So the shoebill is really the hardest counter to the lungfish. There's this BBC video that I feel like catfished me because it's titled "The Unusual African Lungfish Battles a Stork." So I was like, oh, I'm going to watch this video to see how the lungfish is able to fight off this shoebill. Maybe this is like going to be something I can include in my notes for some way it can defend itself. So I watched the video. It's just a shoebill eating a lungfish with no issue whatsoever. I felt so cheated because I felt like I was promised a battle. There was no battle to be had. It was over instantly.
This goes back to the idea of a shoebill eating a lungfish in a lungfish documentary versus a shoebill documentary.
I know. It felt like it felt like they were trying to portray the lungfish as this like brave hero.
A lungfish wrote this documentary.
And the shoebill really just picked it up and went on about its day. I was like, where's the battle? Huge disappointment.
Brave lungfish fights to the bloody end.
Basically, there was just nothing he could do about it. I was like, okay, all right. If this is the best you've got, I had to dock a point for no defenses whatsoever. Next category for the West African lungfish is ingenuity. I give it a 7 out of 10. So this goes back to the thing I was talking about, how it survives the dry seasons. So during the dry seasons, this fish has to survive in a dried up riverbed for months at a time. So to get by until the next rainy season, the lungfish burrows down into the mud by chewing. So it just chomps down into the mud and it spits the mud out through its gills. So once it's deep enough to cover its whole body, it wiggles. Yeah. It wiggles around to like hollow out a little cave, basically with this narrow opening that opens out into the air. So it has air to let in. So since it does this kind of like towards the end of the wet season, there's enough water in there already that it has kind of this little water-filled chamber. So it sits in this water-filled chamber, just hangs out with its sort of nose poking out to reach the air. But then when the mud layer dries out, the water drains basically from its little cave. And what it does then is really interesting. It secretes a slimy mucus out of its body that then dries. And it forms a cocoon around the lungfish. And it just waits in this booger cocoon for months at a time until the rain comes back.
So is it still in water at this point, or it's
at this point the water's dried out? So it makes the snot cocoon in response to the water in its burrow being drained.
Okay.
And then at that point, the metabolism in its body slows down to this glacial pace where it enters this period called estivation, which is just hibernation when it's hot. If it's cold, it's hibernation. If it's hot, it's estivation. Yeah. So they estivate, where their body is basically just on minimal function only. They're not moving. They're not eating. They're not pooping. They conserve energy for months. They can hypothetically survive in this state for up to 3.5 years.
Wow.
Yeah. With no break. Like literally just vibing for 3 years with not moving. Well, they don't usually have to go that long, right? Usually it's only like 6, 7, 8 months before the rains come back. And it's usually not that big a deal. But while they're in this state of estivation, their body survives by digesting muscle tissue that's stored in their tail. Yeah. And it just gets them by until they're able to come out of estivation and swim around and live a happy fish life.
Wow.
Yeah. Last thing for ingenuity, I promise this is going to be quick. I did want to include parenting in this because we don't often get to talk about fish parenting. Usually fish just kind of spawn their babies out and wish them the best and don't have a lot of involvement in the life of the young. But so female lungfish lay their eggs in their nest, and then once the eggs hatch, male lungfish protect their young. They guard their babies for up to 2 months. Which is quite a while, considering most fish don't do anything with their babies, you know? Lungfish are good dads. Just wanted to include a little bit of credit for lungfish dads, that they're doing great.
That's a little bit like the catfish.
Yeah. I did actually, like, while I was doing my notes, I felt like, I was like, I'm getting real catfish, like, vibes from the lungfish, which makes sense because it's another kind of, like, muddy, like, freshwater fish. Probably some convergent evolution going on there.
Yeah.
Final category, aesthetics. I'm going to wrap this one up quick. 6 out of 10. There's nothing, if you were to look at this fish without knowing any of the context I gave you earlier, it doesn't look like an exciting fish. you know?
Yeah.
It looks pretty bland. It's kind of a drab, like gray brown color, and it has these black spots on it. That can be kind of cool. They can look a little bit like leopard spotty kind of in some ways. They have a thick, broad snout with tiny little eyes, which I think is like kind of cute a little bit. I like a chunky fish. Like, I'm into that. I like a chunky fish.
Yeah.
The noodle arms are really funny. Like, it's more funny than anything, really. The tail is shaped like a leaf, or maybe kind of like a feather almost, which I think is nice. Yeah, I like a chunky fish. This is 6 out of 10, but nothing wild.
Sure.
I would have given them higher if they maybe had some pretty colors or something like that. I would love to see a splash of red on this guy. Okay, so to wrap things up for the lungfish, miscellaneous information. Their conservation status is least concern. They have a very wide range. So they're found in huge swaths of a massive continent, so they don't necessarily have a habitat shortage, and they have no major threats to its population that have been identified, other than maybe the shoebill. But the shoebill is in a more precarious conservation situation than they are. So they are more populous than the shoebill. Okay, so the last thing I wanted to say for the lungfish, during my research, while I was toiling in the internet mines, I found a diamond.
Oh boy.
I found a gem on the internet. I struck gold. This is a track on Spotify.
Oh boy.
The track is titled Devonian, which is the name of the period of time when there was this big boom in fish evolution. The Devonian period gave us such classic hits as lobe-finned fish, as well as sharks and ray-finned fish. So just big period of time associated with fish evolution. And this is a track on Spotify called Devonian, which is the only track released by artist Lil Lungfish.
Oh.
And it is a rap about the Devonian period and tetrapod evolution. And it is in fact like about the Devonian period.
Okay.
And that's what I found.
Does it slap?
I mean, that's up to the listener to decide.
Yeah, we don't talk about subjective qualities.
That's true. We've never done that on the show ever. We've never arbitrarily given opinions to things. Yeah, go check it out. It's called Devonian. It's by Lil Lungfish. And I will say, this track on YouTube has 21 plays.
Okay.
So when I say this is a deep cut on the internet,
all right,
get in now. Like, invest on the ground, like get in before it's viral.
All right.
Yeah. So that's the lungfish.
Thanks.
You're welcome. If you heard me in the kitchen while I was doing my notes vibing to an inexplicable rap song, that's what that was.
Fantastic.
Yeah. Well, thank you so much to everybody who has joined us today. And thank you to everybody who has been leaving kind reviews for us on your podcatcher. That means a lot to us. Thank you so much for doing that.
Thank you.
You can connect with us on Facebook, Twitter, or Instagram, or Discord, or TikTok. Search the title of the show on your favorite social media platform, and you shall find us. If you have an animal species that you'd like to hear, you can submit those to us at my email address, which is ellen@justthezooofus.com. I would like to thank Maximum Fun for having us on their network with their other wonderful shows. You can check those out. And also, if you'd like to support us financially, that would be lovely. You can do so at MaximumFun.org/join. Sign up for a membership. It supports us. It supports your other favorite shows on the Max Fun network. We would love that if you could do that.
For sure.
That would be so nice. No pressure. Don't do it if you can't. Just saying it would be nice. And finally, thank you to Louis Zong for our theme music, which you're about to hear right now.
It's good.
It is. We will talk to y'all soon.
Bye, y'all.
Bye.
MaximumFun.org.
Comedy and culture.
Artist owned.
Audience supported.